Hello, I think we're up to number 6 today. Today we're talking about nitrogen and specifically the nitrogen cycle. Now, in the previous session when I spoke about amino acids, I did not mention that they all contain nitrogen. Now, if you remember when we talked about carbohydrates, we said as the name indicates, they comprise of carbon, hydrogen, oxygen, those 3 elements. Now, of course, it doesn't mean that anything that has all these 3 is a carbohydrate, and I mentioned that before. However, when it comes to amino acids, over and above carbon, hydrogen, and oxygen, they have nitrogen. And this nitrogen is in the so-called amine form, which is NH2, nitrogen and hydrogen. That's called chemically amine. So amino acids are compounds that have this amine group on one end and acid group on the other end. Anyway, so where do amino acids get their nitrogen from? Or in other words, I should rephrase the question and say, where do plants get the nitrogen from to make the amino acids? Now, the biggest store of nitrogen on Earth is the atmosphere. 78% of the atmosphere is made of nitrogen, 21% is oxygen, which adds up to 99%, and all the other, like rare gases, including carbon dioxide and all of that, they all make up to 1%, but of course carbon dioxide is a very, very small percentage. Now, but this nitrogen, however, is not available for use. Actually, the word nitrogen, a lot of these elements that have been given names in the early days, have names that indicate meanings, in fact, because the word nitro from that component in nitrogen refers to neutrality. So nitrogen, this is the substance, the element that generates neutrality. Oxygen generates oxides, you see, makes sense. Hydrogen generates water, because hydra is water. So these meanings, etymologically have some reference, So nitrogen in the air, in the atmosphere, is inert. I mean, can you imagine what would happen if it wasn't? I wish, I could ask this question and get answers here. Imagine if nitrogen and oxygen could react under just normal temperature and pressure. What would happen? What would happen? We'll have no oxygen left in the atmosphere. It will deplete all of the oxygen because there's also more nitrogen than oxygen. So oxygen will run out first, and we'll have an atmosphere. Instead of being comprised of nitrogen and oxygen, it will be comprised of whatever left of this nitrogen, and the rest will be nitrous oxide or nitric oxide. But this fortunately doesn't happen. It does, however, happen in the case of, apart from the biological process, which we'll be talking about, if there is lightning. When there is lightning in the air, when there's electric activity, that will generate a lot of heat. And that heat will produce a chemical reaction, will facilitate a chemical reaction between nitrogen and oxygen. They will react, and some nitric oxide gas will be formed, which will dissolve in the water, in the rain droplet, and fall down. So some people will say that rain brings in nitrogen. Yes, true. It is true, but only if there is lighting activity, if there's electrical activity in the heavens. So this chart here represents what we call the nitrogen cycle. We'll have a copy of it, posted like we've been doing with other stuff. Now, there are many similar cycles in nature. The simplest of which is perhaps the water cycle, which is very easy to understand, very easy to elaborate. You've got water in the ocean, it gets evaporated, it goes to the atmosphere, it forms clouds, then the clouds rain, the rain will wash down in the soil, it will feed animals and plants, some of it will run into the rivers into the oceans and back into the ocean again, and the cycle repeats itself. In the case of nitrogen, it's a little bit more complex because there's chemical changes involved. In the case of water, the water doesn't change nature, it's still water. It just changes form. In the case of nitrogen cycle, what you have here is nitrogen in the atmosphere. In the case of lightning, it changes into other forms of nitrogen, which are more complex, and which will dissolve in the water, in the rainwater, and goes into the soil. Okay? Now, there is another process here, which actually involves bacteria. So in the soil, there are what we call nitrogen-fixing bacteria. They will take this nitrogen from the atmosphere and combine it with oxygen, also to produce the same thing. Ammonia, look, different products. Let's not worry about the details of it here. The important thing is that nitrogen is obtained or sourced out from the atmosphere, and it's changed into another form which can go into solution. It can go into the soil solution. It is now available for the plants to take up. Now, there's many different types of these nitrogen-fixing bacteria, and we will talk about them later on. But we're getting there, you see, we're beginning to talk about plants here. All right, so this nitrogen now is either in the form of ammonium or in the form of nitrate eventually. The plants can take it up. Okay? Now, this is a very simplified nitrogen cycle. The plants now are able to take it up. When they take it up, they're able to transform it to amino acids and then protein. And then when the plants decay, if you put organic matter in the soil, some of that nitrogen will again get denitrified. Okay, so that process of nitrification will be reversed, and some of that nitrogen will go back into the atmosphere. And that's the cycle. That's the cycle. Now, this is the natural cycle of nitrogen. Why am I saying natural? Because mankind has been able to interfere with it and change it a little bit, add another factor to it, for better or for worse. Why is this? Why did we have to do this? Why did we have to involve technology in this? As you see in this process here, there are two sources of nitrogen to go into the soil, either through lightning or the nitrogen-fixing bacteria. No other. There's absolutely no other. So there is a limited supply of nitrogen to go from the atmosphere into the soil. I think the estimates are about 120 million tons a year, which may sound like a lot. Okay, it is a lot. But when you have so much expectation out of the land, you want to produce more out of it. You want your acre or hectare, whatever, instead of producing, let's say, 2 tons of wheat, you wanted to produce 3-4 tons of wheat, 5 tons of wheat. Okay? Then this amount of nitrogen coming to it naturally becomes insufficient, and you need to supply. You need to supply it with additional amount of nitrogen. And this is where the concept of fertilizer came in. Nitrogen fertilizers. Other fertilizers are different. They've got nothing to do with this kind of a cycle. So add to this and that, we have added another industrial factor here, which is not on this chart, which takes nitrogen from the atmosphere and chemically binds it to hydrogen in a process. Let's not worry about its industrial name. That's not the important thing here. And then this ammonia that is formed, again, is either used on its own. Ammonia gas can be used as a fertilizer, or they combine it with carbon dioxide to form urea, which is the most common form of nitrogen fertilizer. And the amount of nitrogen that is added to this cycle anthropogenically, in other words, by human action, is almost equal to what comes in naturally. And this is how advances in agriculture have been able to produce more food for a growing population. Now, this is the thing that we need to understand. And again, I'm not here talking, I'm not lecturing, I'm not giving you lectures about what's good for the future of the planet, or should we do this or shouldn't we do this. But the fact remains now, as it is that we've got nearly 8 billion people on the planet. For us to be able to feed them, and that's the first thing that I learned when I went to ag school, is that you need to be able to increase your production vertically, not horizontally. Yes, but what's the difference? Horizontally means you grow more land. Okay? There is a limit to this. There's still a lot of areas on Earth that haven't been used for agriculture. I understand. But if you want to increase productivity, you have to increase it vertically. In other words, you have to work a way to increase your production per unit area. If you can do both at the same time, that's even better. So now we are in a situation where we have 8 billion people. And the only way to produce enough food for them is to add to this natural cycle another factor here that employs technology, that employs the use of synthetic fertilizers. Now, anyone who says you can do it any other way, I would like to see what the answer is. I'd like to see what options are they giving us. I don't think there is one, as far as I know. There isn't one. So this really means also is that in as much as we would like to be able to stay away from synthetic fertilizers, if the whole world, hypothetically speaking, goes into growing food organically, as in without using any chemical fertilizers, we won't be able to feed the 8 billion people that we have on this planet. That's a fact. This is an absolute fact. So, back to your gardening hobby, ventures, adventures, whatever you want to call them. If you want to grow plants for food, you have to seriously think about where this nitrogen is going to come from. Are you able to apply it in an organic form? If you are, good, fantastic. If you can't, you're going to have to use synthetic fertilizers. There is no other way. If you don't do either this or that, you're not going to be able to produce the quantities that you like at the time that you like. Thank you for listening.